Hello, this is Mr. Spy, and this will be the last lesson in Unit 2 on piecewise linear functions. So, graphing linear piecewise functions and evaluating linear piecewise functions. So, what is a piecewise function? A piecewise function is a special function that you have a different rule based on which number you're working with. So in this case, you have two rules for this function, rule 1 and rule 2. Use the first rule when x is less than or equal to 3, and use the second rule when x is greater than 3. So let's try a few numbers. Let's say x was 2. So I wanted to find f at 2. So since 2 is less than or equal to 3, you use the first rule. 2 times 2 plus 5, and that will be 9. Let's say you wanted to find f at 7, not f at 8. We'd use the second rule, because 8 is greater than 3, so half of 8 minus 3 will be 1. The most important number to look at is also the number where it switches rules. In this case, where it switches rules is the number 3. So you'd use the first rule, because 3 is less than or equal to 3. So f at 3 will be 2 times 3 plus 5, which would equal to 11. Okay, so that's how piecewise functions work. Let's practice evaluating one. Now in this case, they give us 3 rules. And I advise you before you're doing anything, make sure you understand the restrictions for each of the rules. So when you have a piecewise function, there's always restrictions when you could use which rule. So the first rule, the restriction is x is less than or equal to negative 1. So x has to be less than or equal to negative 1. Second rule, negative 1 less than x, less than or equal to 4. So x has to be in between negative 1 and 4. We want to include 4. And the last one, the third rule, x has to be greater than 4. And you plug in each number. 5 is greater than 4, so you use the first rule, the third rule. Since 5 is greater than 4, use the third rule in this case. So half greater than 5 minus 3. So half of 5 is 2.5. 2.5 minus 3 is negative 0.5. Then for the second one, 2. 2 is in between negative 1 and 4, so we use the second rule for number 2. So half, 1/3 of 2 plus 1. That's 1 minus 2/3, which is 1/3. Then negative 5 is less than negative 1, so we use the first rule. So that'll be 2 times negative 5 plus 5, which would just be negative 5. Now, negative 1 works in the first rule, because the first rule is when x is less than or equal to negative 1. So you do 2 times negative 1 plus 5, which would be 3. And last but not least, we want to find what the value is at 4. Well, 4 is in between negative 1 and 4. And we use the second rule when it's also equal to 4. So we use the second rule, so that's negative 1/3 of 4 plus 1. So negative 1/3 of 4, that's negative 4/3 plus 1. Ooh, negative 4/3 plus 1. So that's negative 4/3 plus 3/3, which is negative 1/3. Be careful with the negatives, be careful with the numbers, and be careful to use the correct rule each time. Copy down whenever you need to, and then we'll go on to the next slide. So find the y-intercept. It's when the plug 0 into the equation. So you find f at 0. At 0, you'd use the second rule. So that would be negative 1/3 of 0 plus 4, which equals to 4. So the y-intercept is at 0, comma, 4. The x-intercept, though, is when each equation equals 0. And then you have to test the restrictions. So you first do 2x plus 5 equals 0. Then you'll do negative 1/3 x plus 1 equals 0. Whoops. And then you'll do 1/2 x minus 3 equals 0. Okay? So the first one you'll solve for x equals negative 5 over 2. Negative 5 over 2 is less than or equal to negative 1. So this one works. Okay? Next equation, negative 1/3 x plus 1 equals 0. You solve for x. So negative 1/3 x equals negative 1. Multiply by negative 3. If x is equal to 3. X equals 3 is in between negative 1 and 4, so that works. And last but not least, you set the last equation in half. X minus 3 equals to 0. Add 3 on both sides. Half of x equals 3. So x equals to 6. 6 is greater than 4. So that one works out too. So that one is also yes. Let's go on to the next one. Okay? Sometimes we'll ask you to find the average rate of change. So you plug in both your values. So you're going to plug in f at negative 2 and f at 6. So since at negative 2 you use the first equation, that's 2 times negative 2 plus 5, which would be 3. No, not 3. 2 times negative 2 is negative 4 plus 5, which equals 1. Then you find f at 6. Use the last equation. Half of 6 minus 3 would be 3 minus 3, which equals 0. Okay, once you have your values, you make each one into a point. So you have negative 2, comma 1, and 6, comma 0. Then using those 2 points, you find the average rate of change. So the average rate of change, would be the difference in your y's, so 0 minus 1, over the difference in your x's, which is 6 minus negative 2. 0 minus 1 is negative 1. 6 minus negative 2 is 8. So your answer would be negative 1 over 8. Okay, copy down what you need to, and we'll go on to the next slide. Now, this is where I'm going to start the next video. I'm going to stop this video and break it up into 2 parts. The first part will be evaluating functions. The second part will be how to graph and how to read the graph of piecewise functions. Then I'll end off with something that's not linear. Hope this was helpful, and I will post the second part of this video later. This is Mr. Spy, signing off.